It seems more and more we hear Christianity is at war with the theory of evolution. But this doesn't just come from atheists. Many Christians are in complete agreement with this idea and speak out against the theory of evolution, calling it anti-scientific, lacking any data, and completely incompatible with the scriptures. Growing up in a very conservative church, I had this beaten into me over and over. Evolution is evil, unscientific, lacks any evidence, and is completely and utterly incompatible with the creation account in Genesis. But is it really? Many people end up rejecting Christianity altogether, not even giving it a second look, because the church hammers this idea into them, that to be a Christian means you must reject evolution, even though they may have become convinced by the evidence for it. They end up throwing out their faith altogether over such a minor issue, because many Christians have told us you can't be a Christian and believe in evolution. On the other hand, many Christians become so convinced by one possible reading of Genesis, they refuse to even consider the fact it might be possible for someone to be a Christian and believe in the theory of evolution. Perhaps the supposed war is an illusion, and there really is no conflict at all. So I want to try to present a case that Christianity and evolution are 100% compatible. I understand many Christians will still want to reject evolution, even if I can show you can be a theistic evolutionist and a Christian, because they believe evolution is unscientific and lacks any data. It is not my intent here to argue scientifically for the theory of evolution, but to argue that even if evolution is proven true, it will not threaten the validity of the scriptures. So this will be done in 2 videos, and I'll deal with 2 big objections many Christians have when faced with the idea Christianity is compatible with evolution. So my case will be built on both videos, not just what I lay out in this one. The first objection many Christians have is the Bible says that we were created with purpose by a good God. Evolution teaches we are an accident. We arrived here by random chance through a process without any intent, direction, or purpose. Well, this belief is not entirely true about the theory of evolution. In fact, what I just said is not really correct, because technically, there is no theory of evolution. There are actually theories of evolution. Philosopher of science Joshua Moritz lists several different views on how evolution happens, from Lamarckian evolution, Darwinian natural selection, Neo-Darwinian evolution, niche construction, evolution through symbiogenesis, evo-devo, process structuralism, and others. What I have just described was the theory of evolution of Neo-Darwinism, which specifically teaches that evolution is change in gene frequencies in populations. In other words, it is the idea that when a species produces offspring, random variations in genetics will occur, and this slow process of variation is the driving force of evolution. Neo-Darwinian evolution is driven by chance. It takes Darwinian natural selection and combines it with Gregor Mendel's work in genetics. It theorizes that evolution specifically happens by random changes in the DNA of offspring when passed on. Under this idea, all is random. How we got here was by luck or chance. It was not directed by any natural law or processes. As Stephen Jay Gould said, if you were to rewind the tape of life back to zero and start evolution over, you would not get human life or anything like what exists now, but something totally and completely different, because evolution is so random and entirely based on chance. This is the current paradigm among evolutionary biologists now, but as Joshua Moritz notes, this technically was not Darwin's view. Darwin clearly did believe there was randomness at work, no one doubts that, but he did not believe there was definitely only randomness at work, like with Neo-Darwinianism. When he talks about randomness, he leaves open the fact there could be some cause or direction being maintained in the evolutionary process, something like an undiscovered natural law which directed these evolutionary processes and constrained the amount of randomness that could occur. So this brings me to my next point. Even though the current majority of evolutionary biologists hold to the Neo-Darwinian synthesis, it is not the only game in town. Yes, all views of evolution agree there is randomness in the genes you pass on to your offspring, and that randomness is a factor in the evolution of life. But some theories allow for a theory of evolution that is goal-directed and constrained in certain ways on how life can evolve. And the evidence is beginning to cause a number of scientists to suggest the neo-Darwinian theory needs adjusting or replaced. For example, niche construction says organisms do not just adapt to environments through the chance of random variations in offspring, but that organisms shape environments just as much as environments shape them. As Paul Griffiths and Russell Gray say, organisms and their ecological niches are co-constructing and co-defining. A good example is the beaver dam or bird's nest, where a certain species will shape the environment they are in, instead of being completely subject to the environment and being forced to adapt entirely. Humans are, of course, the masters at this. Kevin Leyland and his co-researchers say, organisms not only shape the nature of their world, but also in part determine the selection pressures to which they and their descendants are exposed. So it is not all random luck. As organisms grow in intelligence, they are able to change their environments and determine their own selection pressures, and give their evolutionary path some direction. This idea of there being direction in evolutionary processes is important, and we'll talk more about this later. Epigenetics has also modified our understanding of neo-Darwinian evolution. Epigenetics is the theory that environmental factors can cause changes in a species' DNA that is passed off to their offspring. For example, studies on fruit flies have shown epigenetic markers for up to 13 generations later. A study has shown that what a mother eats while pregnant will modify or shape the DNA of the child inside her. Environmental factors that lead to depression may also change your DNA. So we do see environments directing or shaping organisms through epigenetics. It is not all random variation in genes passed on, but environments do play a role in directing certain characteristics to come about. Going on that basic idea, many scientists have challenged the neo-Darwinian thesis to its core by arguing there is evidence of direction or progress in evolution that cannot be adequately explained by the neo-Darwinian thesis. The most vocal in the past decade has been paleontologist Simon Conway Morris. As neo-Darwinist Stephen Jay Gould thought, if you rewind the tape back to zero and start evolution all over, you would not get anything like the speciation we have now, let alone human life, because everything came about by dumb luck or chance. Morris says if you started evolution over, you would get human life again, or something very similar. If you then started evolution again, the same result would happen, and again and again. What Morris is arguing from is a position known as process structuralism, which states, as Joshua Moritz says, maintains that the kinds or types of organisms that we see, their body plans, and many of their traits, are the result of natural laws, rather than being merely the byproducts of historical contingency and chance genetic mutations. There are natural laws that govern the evolution of biological structures in organisms. In other words, the evolved life that we have is an inevitable result of natural laws. The natural laws of the universe are finely tuned to bring about life as we know it. So in other words, the evolution of humanity, or something very similar, was inevitable and would be on any other planet if life were to occur there. As Robert Barry remarked, if we ever succeeded in communicating with conceptualized beings in outer space, they won't be spheres, pyramids, cubes, or pancakes. In all probability, they will look an awful lot like us.
It's a theory which claims that a lot of the order of the biological world arises from natural law, or what the pre-Darwinian biologists called laws of form. Owen called it a polarizing force. He didn't understand what they were, and he was wildly speculating. But that's the theory, that a lot of order arises, and so the biological forms are like crystals and galaxies and atoms. They're part of the changeless order of the world generated by universal laws of form. Owen said if we go to another planet, we might find vertebrates. The same basic design. At the end of On the Nature of Limbs, he speculates, well, there will be vertebrates on other planets. In other words, on other planets, the same laws of form, the same laws of nature will generate the same forms of life we see on Earth. So that's it. It's the idea. It goes back to Aristotle's forms, that the biological world consists at its base of a series of what Owen called primal patterns, or basic forms generated by laws of form in nature. So that's structuralism. It doesn't say that all the order, it's not explaining all the order of the biological world. It doesn't explain adaptation. It's an attempt to explain the bow plans, the basic plans. why we have insects, why we have vertebrates and things like this. The basic underlying patterns which underlie the basic taxa in the world.
The evidence process structuralism draws on comes from evidence of convergence in evolution. We know how evolution creates divergent species. One species splits into two separate species, even though they have a common ancestor. Thus, they diverge along different paths. But what we also see in evolution is hundreds of cases of convergence, where organisms not closely related independently evolve similar traits, forms, or physiology. A common example is the form of the shark, dolphin, and the ichthyosaur. Each of these species evolved independently to look similar, thus they all converge to the same point. Randomness in evolution obviously does happen, no one denies that. You can even see differences between these three. But Morris's point is evolution is constrained to a certain degree, not unbound and unlimited possibility. Nature is designed to bring about certain characteristics in evolution, or that certain features are an inevitability guided by natural laws. Plus, this is just one moderate example. There are far better and more abundant cases of convergence that Morris covers. Take a look at this saber-toothed tiger. Sorry, this is actually not a saber-tooth. This is a South American marsupial that went extinct. This is a saber-toothed cat. But as you can see, both evolved independently on different continents to have almost identical characteristics. Yet this one is more closely related to a kangaroo, and this one is more closely related to a giraffe. But this is just one example of convergence between marsupials and placenta mammals. John Kirsch notes several examples of convergence between the two groups in brain structure and sensory input through stereoscopic vision and whiskers, yet both groups evolved these features independently on different areas of the globe. The last common ancestor did not have these convergent features. Another interesting case of convergence is the evolution of the camera eye. This has happened in vertebrates. However, this also happened independently in cephalopods and annelids, and all three forms are almost identical and have the essential features of a camera eye. Beyond that, it is agreed eyes have evolved independently multiple times. A classic paper states, summing up the different and convergent sequences towards eye perfection in general, there are about 20 or even more independent lines of differentiation, including at least 15 cases of independent attainments of photoreceptors with a distinct lens. Bob Baker cites 6 separate evolutionary lines that have all converged in multiple ways within placenta mammals, and argues that this is clear evidence of directional natural selection, not random walk-through genetic drift. And this is only scratching the surface of the hundreds of examples of convergence, like the similar form of the mantis and the mantispa, or Kirk Weinmiller's repeated evolution of eel-like morphology, or the same structure seen in this particular cactus of the Sonoran Desert to a type of spurs from East Africa. There are just dozens upon dozens of examples. Stuart Kaufman says, "The emerging sciences of complexity begins to suggest that the order is not all accidental, and that vast veins of spontaneous order lie at hand. Laws of complexity spontaneously generate much of the order of the natural world." In other words, complex organisms are not accidental products of chance. Kaufman argues there is a natural law-like source beyond mere natural selection that purposefully brings them out. And the evidence is in dozens of examples of convergence, like the independent evolution of anthropodization, eusocial organization, compound eyes, courtship behaviors, family structures, antifreeze proteins, C4 photosynthesis, proteases, peptidases, and many dozens of other examples. Adaptation shows convergence, and convergence infers evolution is not meant to be completely random, but a directional process that focuses on bringing a limited amount of certain features to life. From all this data, Simon Conway Morris looks at the evolution of intelligence and asks if the evolution of humanity was an accident, or if it was an inevitable consequence of nature. He first notes we are unique in the level of intelligence we have over other creatures, but also notes if humans did not first emerge with our massive brains, it is very likely another creature would have eventually, because there are multiple examples of convergence in intelligence and the evolution of larger than normal brains and species. High levels of intelligence have developed in several species from corvids, dolphins, whales, elephants, and other primates. Nicola Clayton says, "Corvids are particularly good at solving laboratory tasks that rely on the ability to abstract a general rule to solve the task and transfer the general rule to new tasks. They also have extremely large brains relative to their body size, live in complex social groups, comparable to that of chimpanzees, have a complex understanding of social cognition, and have a limited understanding of physics. Since at times they are able to choose the appropriate tool to solve a task in an experiment, and other experiments have shown that crows can manipulate man-made objects to solve problems. Clayton concludes her paper by saying, "We conclude that the intelligence in both corvids and primates has evolved through a process of divergent brain evolution, yet convergent mental evolution." Dolphins and other cetaceans have also converged in regards to intelligence. In fact, up to about 1.5 million years ago, dolphins had the largest brains on Earth relative to their body size, and it appears their level of intelligence is very high compared to that of other animals, and similar to ours in certain ways. David Smith and his colleagues even remarked, human and dolphin uncertain responses seem to be interesting cognitive analogs. Lori Marino says humans and cetaceans represent two fundamentally different cortical organization themes, and thus compels the conclusion that any similar complex cognitive processes between primates and cetaceans are convergent. Many studies show high levels of intelligence in dolphins, like self-recognition in mirrors, a possible language development, and a high level of cognitive ability. Thus, high intelligence has evolved independently on other lines of evolution. Within primates, there is clear evidence of intelligence evolving on multiple lines, as well as the ability to walk on two legs. A good example is seen in the convergence of Old World and New World primates. New World monkeys known as capuchins have been shown to have complex social structures, ingenuity, and a high level of intelligence, including the use of tools. This led researcher Martin Moynihan to say, with all their limitations, however, capuchins can cope with some classes of stimuli with remarkable ingenuity, almost unparalleled below the level of man himself. This is why Simon Conway Morris concludes the evolution of humans, or something like us, was inevitable. If we hadn't walked out of Africa, then probably sooner rather than later, our analogs would have strolled out of South America holding tools. The amount of convergence towards intelligence in primates is pretty remarkable and has been observed throughout the genus. Bernard Wood says, key hominid adaptations, such as bipedalism, manual dexterity, and a large brain, are likely to have evolved more than once. Thus, intelligence appears to be an inevitable consequence of evolution and adaptation, not something that appeared because of random chance or luck. It could possibly be that our existence was an inevitable fate the moment life began. So given all this convergence, evolution appears to have a rational structure, and if that is the case, why would it contradict Christianity?
Well, what we see here, from what we looked at today, the highly structured and convergent evolution of life through organized processes, self-organized processes that seem to be directed by law. That's what we saw today. We have these processes that appear to be directed by some sort of physical law. For Christians, if we go back to the early church, natural law is just the scientific way of referring to God's will for creation, since God is ultimately the one who created these laws for creation to follow, or for nature to follow. And this has been a long-held Christian view. Laws of nature are not anti-God. These are God's will. This was what Augustine and Basil and others we talked about said. This scientific understanding of the emergence and complexification of life is exactly what we should expect to see from the Hebrew terms yatzar and asah, which are used to describe both God's creation of an embryo and God's creation of complex plant and animal life. And so here, if we take this process structuralist, self-organized, evolutionary developmental biology view, we see something extremely similar to the development of an embryo in the development of life.
So if evolution doesn't automatically equal neo-Darwinism, then we could hold to a theory of evolution, like process structuralism, and there would be no reason Christianity would be incompatible with evolution. I know there are many Christians who will still deny evolution, due to our lack of understanding and how certain complexities could evolve. But even if those get sorted out in the future, it will only demonstrate the creation of life happened through evolution, not create any challenges for Christianity. And as a Christian, there is no reason to think the theory of evolution is the enemy of the Bible. Plus, as the recent decades have shown, the neo-Darwinist paradigm is beginning to change. From epigenetics to convergence, the evidence is piling up. Random variations in genes cannot fully explain the evolution of life. And a more complete theory of evolution may lead us to a theory where evolution is rational and has direction. And life as we have now is an inevitability, rather than just brought about by chance.